Thank you for the introduction. Yeah, my name is Joe David. I do work for Point 32, and we are a real estate development company based in Seattle. And again, I really just want to take the next few minutes and provide the perspective of a consumer trying to navigate the world of selecting toxic-free materials. A construction project may contain up to 1,000, perhaps 1,500 distinct parts and pieces, products, valves, fittings, bolts, and siding materials, and they all really kind of weigh in on this issue. So I'm going to use the Bullitt Center as a case study. This is a project that we completed in April of this year. This is a 52,000 square foot office building in the Capitol Hill Central District neighborhood of Seattle, Washington. It's really endeavoring to do a lot of things that most commercial buildings don't. One, it is designed and is being operated to generate all of its own electricity on site through that 14,000 square foot solar array on the roof. It is also designed to be a net zero water project. So all the rainwater that falls on its roof gets captured in a 56,000 gallon cistern in the basement. We filter and treat water on site for potable and non-potable uses in the building. And also it's we're endeavoring to be net zero waste in a kind of a unique way. The building has 6 stories of composting toilets. So instead of creating sewage and discharging to the combined sewer system, we create field-ready compost in the basement. And again, the policy and regulatory changes that went along with that have been quite exciting, and we're hoping to see more of these projects in the Seattle area and internationally as well. Okay, so I'm going to kind of frame the goals of this project with a quote by Dennis Hayes, who is the director of the Bullitt Foundation. And he says that our desire is to open a wedge into the future so that we can see what is possible in a contemporary office building. This project needed to be profitable. It's owned by a small philanthropy, so it's part of their investment portfolio. But it also really aims to be a game changer. Dennis went on to say that if this is a standalone project or a unique project in 5 years, we will have missed the goal entirely. We want to uncover successes, failures, and share that with the green building community throughout the world. Again, here's proof that it's not always cloudy in Seattle, but most of the time. Here's a shot from the interior of the building. This is a heavy timber construction building. We're using regional materials, and you can see it's quite a pleasant place to work. I'm fortunate enough to say that that's a photo taken from my desk, so happy to be there. And then on the first floor of the building, we have the University of Washington as our primary tenant, and they're actually advancing this educational mission that comes along with the building. This is a resource center for the local green building community, and certainly any of you are welcome to come visit us in Seattle. We do tours of the building out of the space, but really what we do is mine data from all the sensors, meters, indoor air quality testing, and we share those results with the community at large. Okay, so now for the toxics piece. To set the context, I think regionally, I'm going to lean pretty heavily on a few articles or studies that have come out. Seattleites are generally pretty aware of the prevalence of toxic chemicals in the Puget Sound, in the saltwater kind of body that makes up the port of Seattle, really. And this is an article a study that the University of Washington released saying that killer whales have the highest concentration of toxic substances like pesticides and flame retardants of any creature on the planet. And it's this point that really kind of strikes at the heart of most Seattleites. To know that our dear pods of orca whales are doing quite poorly really raises some flags. This is another study that really starts to tie those trends to the urban environment. This says the study focused on 17 toxic chemicals in the Sound, such as arsenic, flame retardants, and phthalates, because of their potential harm to people, fish, and the Puget Sound ecosystem. In this article, it specifically says that runoff from the roofs of our buildings, from our streets, and again from our urban environments are the likely source of most of these chemicals, especially the flame retardants and the phthalates. So that's where I'm coming from. I am going to share the perspective of a real estate developer who is trying to not contribute to this problem. So given this daunting task to deliver this super green building, the construction team quickly realized we needed a framework to evaluate our decision-making process, our successes and our failures. We settled on this environmental building standard called the Living Building Challenge. Now, the Living Building Challenge addresses pretty common issues in the green building sector, things like responsible site selection, water management, energy conservation. But really the piece that was new for all of us was this materials piece right here. This is pretty new for the green building market. We talk about green materials in the context of recycled content or where the product is sourced, but the issue of toxicity hasn't really come up. So this is how the Living Building Challenge deals with this issue. They endeavor teams to avoid selecting materials that have any of these chemical material groups in their composition. And so that's a challenge. We have to prove to an auditor with a whole bunch of documentation that we've done our very best to avoid these chemicals in the materials that we build these buildings with. And so probably the most ubiquitous tool out there is the material safety data sheet. This is really where we started our process. And again, we're architects, engineers, builders, contractors. We're not chemists or toxicologists. So we're just trying to navigate this world of selecting the healthiest material that we can. So anyway, pretty easy here. Really common building product. And you can see right there on the top, formaldehyde spotted. It's pretty easy for me to match that up with formaldehyde on my red list and move on, right? Find an alternative. But then we start to come across, chemicals like decabromide phenyl oxide, something that's certainly a stumbling block for pretty much all of us that are from this industry. We don't know if this is good, bad, what do we do? How do we react to this when we see it on a material safety data sheet? It became pretty overwhelming. But pretty quickly, we realized that we weren't looking for the names of chemicals, we were looking for the chemical abstract survey numbers. And so we started to mine these off of our MSDS. And using available databases such as the Pharos Project database, we were able to take these CAS numbers and quickly vet them against known red list or avoided chemical lists, including the Living Building Challenge red list. And in this case, our neat little list of 14 chemical groups ballooned to 362 chemicals. And so that became our new red list moving forward. And in this case, we found that that was actually another way of saying halogenated flame retardant and was one of those chemicals we had read about in the tissue of our beloved orcas. So we knew in this case, probably not the right product for the job. So this is our vetting process. When you think about the types of materials that are required to build a building, they really fall into three major categories. Something I'm calling a material, which is something more like a paint or a sealant or an adhesive. It typically comes in a 5-gallon pail, and we typically use a brush or a gun to install it. And there's an MSDS available. Then you've got things like this, an article. This is a small component. This picture right here is actually a lead-free ball valve for a plumbing joint. No MSDS. It's made out of maybe 5 or 6 different base materials. In this case, lead-free. Brass, probably an EPDM rubber dipped handle there, a little bit of stainless steel on the handle, and then, likely some type of stainless washer or nut there. And then you get something like this. This is, technically a pretty sweet piece of equipment. It's a Grundfos water pump, but made up of hundreds of distinct components, the wiring, the circuitry, so on and so forth. And so anyway, that's a pretty daunting task to figure out what red list chemicals might be present in something like that. So our vetting process, and pardon the rather simplistic little decision tree here, looks something like this. We take a material, we get the MSDS, we'd extract the CAS numbers, and then we'd run it through our Pharos database. At best, though, most MSDS probably disclosed 15–20% of the chemicals that were used in the product. And sometimes there would be a trade secret or proprietary stamp on that MSDS. And that really put the construction team in a conundrum. And so we essentially began a campaign to cold call the manufacturers of every product in the building and ask for cooperation or participation in confirming that none of our red listed chemicals were used in their product. And you can imagine that's a huge amount of time and energy for both the project team, but also for the manufacturer. For an article, you can see the process becomes even more difficult. We could ask a manufacturer for the MSDS for the, 5 or 6 base materials that make up that little ball valve, or we can just have them sign a letter confirming that none of those red list materials are any of their base materials. But then you get to something like a pump, and there's a lot of these in the building. It's a really difficult conversation to even begin to enter with a manufacturer. It's hard to know where all the distinct parts and pieces come from that make up that pump. And so to ask for disclosure on percentages of red list chemicals, it was a really, really difficult conversation, and one that sometimes we're able to get a blanket statement saying, yeah, we can confirm that 10% by weight or volume of this product doesn't contain red list chemicals, but beyond that, it was a little difficult. And like I said, we did this for over 1,000 products over the course of 3 years. It was an incredible kind of phone call campaign just to try and get the information to make an informed decision as a consumer. And so we quickly realized we needed to standardize this process. So we created it looks like, according to my slide, an information request, but that was supposed to say information request. They basically asked common questions. Where is the product manufactured? Where are the source materials coming from? Did they contain the red list chemicals, VOC content, recycled content, things like this. And we sent that out to all the manufacturers. And in most cases, we got some level of participation and got these forms back and made the best decision we could about which products to use for our building. On the flip side, though, we're not the only project that's asking this question. The manufacturer is receiving these questions from dozens, hundreds, maybe even thousands of projects, and all the forms look slightly different. The questions are very similar. The red list might be a little different, but it's a tremendous burden on the manufacturers as well to field all these questions. So what you're seeing what's beginning to emerge in the construction industry is kind of this spectrum of chemical disclosure. On one end, you've got the MSDS, which virtually every product has, and it's pretty hard to extract all the information you need to make an informed decision about the constituent chemicals in that product. On the other end is a new label that really just came online probably within the past 6 months called Declare, which requires manufacturers to disclose publicly 99% of the constituents in their product. And again, that presents some serious difficulties when it comes into proprietary formulations and trade secrets. But right down the middle is a form I want to say a few words about. This is called the Health Product Declaration. Now, the Health Product Declaration is basically just a protocol, a reporting protocol that manufacturers and consumers have agreed upon, or many are agreeing is a good way to standardize this information fielding process. Again, here's a quick look at the label. With the last minute I've got here, I'd like to just tell a quick little story. And this is about a company called Proseco and their product Fast Flash. Now, in these high-performance buildings, this is arguably one of the most important layers in the building. That's our liquid applied air barrier. It keeps the rain out, and it keeps the warm, conditioned air in. And we got the MSDS early on. We knew we wanted to use this product, and sure enough, a number of proprietary chemicals. We call up the manufacturer, say, this is what we're up to. We're trying to build a building that doesn't include these chemicals. Will you tell us what your trade secret chemicals are? I said, no. I said, okay, that was expected. And I said, will you tell us what they aren't? Are there any of these red list chemicals? And they said, yeah, we'll take a look at the list and we'll work with you. Got a phone call back about 4 days later. Hey, took a look at your list. We use a type of phthalate in our product. That's what allows it to stretch and flex. I said, well, thanks for working with us. We can't use your product on this building. And they said, well, you don't know what you're talking about. And that was probably true. I mean, it was obviously a tremendous amount of R&D that went into the development of that product. But we got a phone call about a week later that said, hey, really got us thinking. We've been working on a reformulation of this product, and we think there's a way to get the phthalates out of our product. If you can give us 6 months, I think we're going to go ahead and come through with this R&D. So we got a really excited phone call about 5 months later. Hey, come on down to our lab. We just ran this reformulated product through 500 hours of hurricane testing in our test chamber. It's performing quite well. I said, that's great. So we went down and looked, and sure enough, it was passing all of our air infiltration tests beautifully. And that's what's installed on the building, is this reformulated phthalate-free version. Now, what I would assume the manufacturer saw as a liability, right? This new product installed for the first time, really turned into an incredible success story. The manufacturers went ahead and took a look at the installation of this product, saw it being applied, and said, hey, that's great. And they decided to do a wholesale kind of elimination of phthalates from their entire product suite. And so moving forward, all of their products are now phthalate-free, Red List compliant, at least the Living Building Challenge Red List. And I think this is really a testament to the benefit of entering dialogue between consumer and manufacturer. So I'm going to end with that point. Thank you all.